what's happening is that the Earth itself is an enclosed system. The firmament, the lower level of the firmament, is a large Gaussian type of surface. Okay. Now, which basically is just a gigantic capacitor. The Earth acting as the negative ground and the firmament acting as positive. Okay, now how do we know that? Well, one of the things that mainstream science fully acknowledges is that there is an equipotential lines of force that go up at the rate of 100 volts per meter, and it can be measured. And of course, I knew that a long time ago. It never occurred to me. I'm also a ham radio operator, by the way. And, I've been up on a tower several times. You come across ground when you're up a couple 100 feet on a tower, and it'll knock your dick in the dirt, right?
Yeah.
So, yeah, and, worked on top of buildings. But yes, that voltage is absolutely, positively, measurably there. It's acknowledged by the mainstream. Richard Feynman even writes in his books that they have measured it all the way up to 50 kilometers, which would give it a potential at 100 volts per meter of 5 million volts. And if it goes all the way to where I think it goes, to the firmament at 100 kilometers, well, that's 10 million volts as a baseline. All right. So, and this is where we get into the gravity. And actually, I have a video here that I'd love to play just a couple minutes of, David, when you get a second.
Which video? Which video?
It's Zach's video.
With the balloons. With the balloons.
Yeah.
Here, I got it right here. So we got these balloons hooked up to this wire that's hooked up to a Van de Graaff generator. We just got like a metal button on here. And so we have it at equilibrium. And now we're going to charge it up, giving it a positive charge. And as we add the positive charge, it goes down. And as soon as we take, good.
I was going to say, what we need to do is I need to lay the groundwork of this really quick.
Yeah.
Just so we could see. And Ken, I think you may have seen this because Zach said that he thought you actually commented on it.
Yeah, electrostatic charge. I mean, so-called gravity does not exist. I've said that a million times in a million different videos.
I agree.
What you're showing in those balloons where it's actually falling towards the earth because of where you charge is no different than pulling your hand out of a box of styrofoam beads and you're trying to shake the beads off of your hand. It's still stuck to your hand. So, whoops. Hello?
Yep.
I'm here.
Yeah, we're here.
Yeah, I just kicked over to screen share. You guys got my screen share?
Good. Yep, we're good.
Okay, so let me play this for a couple minutes. And basically, this is going to outline this a little bit. And Zach Zabala actually made this. He's one of our associates, and after collaborating with me. And so let me just play this, and we'll get you a little bit better involved here. Oops.
Look at Earth's electrostatic field. This is important because we, along with all the matter in this known realm, are inside of an electrostatic field. The Earth itself has a measurable negative charge compared to the air above it all across the plane. As soon as you leave the surface, there is a positive charge in the air around you that grows in electrostatic potential the further you go up towards the sky. It is a steady, gradual rise in potential, which tells us, according to the laws of electricity, that we are between two Gaussian surfaces. A Gaussian surface is simply a surface that encloses or distributes a charge. If there were only one surface, the rate at which the positive potential grew would be different. Knowing that we are between two Gaussian surfaces, we can also know that certain phenomenon will take place in all matter within the electric field, or area between the two surfaces. For this topic, we will first look at polarization through electrostatic induction.
Now, first of all, Ken, I have to tell you that we don't necessarily believe in the model of the atom at all, but since most people can relate to this as far as how you come up with charged particles, that's why we use this as an example. So I know you don't agree with that part.
That's okay.
But okay, so but it gives you the idea. So
for sake of analogies, that's fine.
Exactly.
Electrostatic induction is a phenomenon where the positive and negative static charges on matter are slightly separated, or polarized due to the electrostatic charge of its surrounding area. If one set of the object's surroundings is positive and the other negative, the negative charge on the object will be attracted to the positive area around it, while the positive charge on the object will be attracted to the negative area on the opposite side. So here on Earth, the positive charge on our bodies is always attracted down towards the Earth, and the negative will be attracted to the air above. This phenomena creates a slight force in that downward vector, because as soon as we leave the ground, we start becoming positively charged by the air around us and are now forced towards the negative of the ground. This is electrostatic acceleration. One might think that the attraction from above and below would cancel out completely, but it is the electrostatic gradient that creates a flow from the positive above to the negative below. Think of the Earth as a flat strainer, and there is a constant flow of water from above, moving very slowly, always applying a force in a downward direction. This would be considered a vector. The electrostatic potential difference getting stronger as you rise from the Earth will keep a steady pressure from above at all times until it reaches the Gaussian surface above. When we reverse the polarity of the electric field and put a negative surface above a positive one, we can reverse this electrostatic phenomenon and get things to stick to the upper plate as if it were the ground. This works with all types of matter. You can move wood, iron filings, and even human hair with these forces. Believe it or not, you can even get water to bend.
Okay, so I'm going to stop that there. And you can still hear me, yeah?
Yep.
Me?
Okay, cool. So, and so basically, Ken, what we're saying is that it is, since we believe that we're in this container and basically we live on the dielectric inertial plane of the Earth. That's the circular part, the pizza part, right, if you will. And we have these Gaussian plates above us and below us, the Earth itself acting as a Gaussian plate. And I don't know if you know this or not, but the deepest hole that's ever been dug, the Kola mines or something like that, is something like 8 miles down, and they cannot go any further down than that. They run into a very interesting substance down there that is virtually impenetrable. So that's what we're
That's in Russia, the deepest hole. I forget the name of the hole though. But
The Bora super hole or something like that.
the only thing they needed
Yeah.
to change in that video is to talk of a negative charge. There's no such thing as a negative charge. Walter Russell said the same thing. We're talking about a ground or a discharge point. So, but that's just splitting hairs, though, of
Yeah.
course. But,
Here's the hole. If anybody cares.
oh, that's a big one. I was think that you're talking about like the deepest borehole, that one in Russia, which
That was the one in Russia.
yeah, the one in Russia, the deepest one's covered over. It's actually a small little hole, even at the top.
Oh, I thought
yeah.
this
Okay.
was all right. Whatever.
I think that
So
one.
anyway,
They made a movie about it too, because when they stuck a microphone all the way down to the bottom of it, they heard these weird voices and it sounded
Like
like
hell.
they were in hell. Yeah.
I'm still freaked out about hearing that.
right. So, okay. So anyway, so basically that's it in a nutshell. There's a lot more detail to it, of course. And, if you have questions, I can try and answer them. But, honestly, I'd love to be able to ask you questions about it. But, going into these assumptions and the cosmologies that have been brought forward from ancient past, and none of us for 1 minute can believe that the ancients were dummies. We don't believe that. In fact, I would say that today's society is far dumber than they were centuries, if not thousands of years ago.
This is true.
Yeah. Okay. So that is what we call the so-called incoherent electrostatic downward vector. Okay, which is our model of gravity, right? Because while it is true that it is theoretically possible that mass could attract mass, and I think you even accept that, The problem that we have with it is we also ran another test where we were doing tests with the little BBs that were magnetic BBs. And we took like 10 of them in a row and we put it next to a Tesla meter, a Gauss meter, and showed that when you line those up north, south, north, south, north, south, the magnetic field, the field strength becomes stronger and stronger and stronger. Okay. But if you take those same BBs and just clump them up in a clump, then all of a sudden they all stick together and everything, but the magnetic field strength goes down to almost nothing.
Correct.
But the interesting thing about that is when you do that, then you can take like a magnet from the outside, a bar magnet or whatever, and it doesn't matter whether you put a north or a south pole to it, it will still stick. So it's an attractive only